afternoon, students.
Good afternoon, sir.
Today I am going to explain about Pythagoras theorem. Pythagoras theorem. So why you got this name means Pythagoras is a mathematician who proved this theorem. That's why we got that name. Pythagoras is a mathematician theorem. So what is Pythagoras theorem? Pythagoras theorem is, so it is a theorem in right angle triangle. This is a right angle triangle. So right angle triangle means one of the angle is 90 degrees. The side opposite to the right angle is called hypotenuse. So this is the hypotenuse and longest side in the right angle triangle. Other two sides are shorter sides. This is the longest side, hypotenuse. Suppose if you give the name ABC to this right angle triangle, the right angle is at B. So what is the theorem is? The theorem explains that, the Pythagoras theorem explains that the square of hypotenuse is equal to sum of the squares of the other two sides. That means AC square is equal to AB square plus BC square. This is called Pythagoras theorem. This is called Pythagoras theorem. Once again, in a right angle triangle, that is the Pythagoras theorem statement. Once again I am repeating, what is the Pythagoras theorem statement means? In a right angle triangle, the square of hypotenuse is equal to the sum of the squares of the other two sides. So that means hypotenuse AC square is equal to AB square plus BC square. In triangle ABC, AC square is equal to AB square plus BC square. This is called the Pythagoras theorem. Okay. How to prove this Pythagoras theorem? How we want to prove is, so diagrammatically I will explain. See here, if you draw the square for the hypotenuse, if you draw the square for hypotenuse, this is a square for the hypotenuse side, and this is a square for another side of the right angle triangle, and this is a one more square I am drawing for the third side. So the geometrical proof of this Pythagoras theorem is, see in the right angle triangle this is hypotenuse. For hypotenuse I drawn one square, and for this side AB also I drawn one square here. And for the other side also I drawn one square. So find out the area of this square and find out the area of this square and this square. So the area of this square is equal to sum of the areas of the other two sides also. So that is a geometrical explanation. If you want, I will explain with the model, one model. So first bench 3 girls and first bench 3 boys come to this side. I will explain it. 3 girls and 3 boys. So remaining also, come close. You also, just stand beside me. Look here, I am explaining to the 3 boys and 3 girls. This is a right angle triangle. I am keeping the right angle triangle here. And this is a hypotenuse. For hypotenuse, I drawn one square. This is a square of hypotenuse side. Next, for the other side, I drawn one more square. I attached it here. Next, for the third side also, I drawn one more square. See here, this is a geometrical proof of Pythagoras theorem. So this square, I measured the sides also. So one side is equal to 35 centimeter, 35.35 centimeter. That means area is side into side. So area I find out 1250 square centimeter we got. And next other side also one more square I drawn. This side is 25 centimeters, side into side. 25 into 25, 625 square centimeters. And this side also square side is 25 centimeter only. 25 into 25, 625. 625 plus 625. Do the chalk please. So this square I got 625. This also 625 square centimeter I got. 625 square centimeter I got. So, and this square area I find out, this we got 1250 square centimeter. Now 625 plus 625. 1250. See here, this 1250 is equal to sum of these two squares area. Na? So this is called geometrical proof of the Pythagoras theorem. So once again, the square of hypotenuse is equal to sum of the squares of the other two sides. This is geometrical explanation, and real proof of Pythagoras theorem I will explain on the board. Go. Close. Okay. See here, I am going to explain the proof of the Pythagoras theorem. First, I drawn ABC right angle triangle. This is right angle at B. That only I have written. First statement, in a right triangle, the square of hypotenuse is equal to the sum of squares of the other two sides. So given is ABC is a right triangle at B. Right angle is at B. Okay. Next, what we have to prove in this means AC square, hypotenuse square is equal to AB square plus BC square. That we have to prove. For proving this Pythagoras theorem, we have to draw one construction. What is that construction? Means BD perpendicular to AC. This we have to draw. BD is perpendicular to AC. That is a construction. In the proof, listen carefully. A pair of triangles we have to take. Pair of triangles. First, what is a pair you have to take? Means big triangle ABC. This is right angle triangle, and again ABB. This is also right angle triangle. Right angle is at D. So this big triangle and this small triangle, two triangles I have taken, and these two I am going to show similar to each other by AA congruency rule. See here, in this big triangle, A angle is there. In this small triangle also, angle A is there. Angle A is equal to angle A because both are common angle. Common angle. Next, in this big triangle, angle B is 90 degrees. And next, in this small triangle, angle D or ADB, three letter name. This is 90, this is also 90. Both are equal, 90 degrees. Therefore, angle. Two angles are equal in two triangles means the two triangles are similar to each other. That means triangle ABC and ABD are similar. So these two are similar. This is a similarity symbol. So if two triangles are similar, their corresponding sides will be equal. Corresponding sides. What are the corresponding sides I have taken? Means in the big triangle AB, in the small triangle AD. This ratio AB by AD ratio is equal to, again in the big triangle AC, another side AC I have taken. This is right angle opposite side. This right angle opposite side is AB. AC by AB. And then I did cross multiplication. AB into AB, AB square. AD into AC. So this is first equation. So now one pair of triangles I have taken. Next, second, one more pair of triangles I am going to take. That is big triangle ABC. And now this second triangle I am taking. Second small triangle I am taking here. So in triangle ABC and the triangle BBC. So in this again, before we have taken AB side, now we have to take BC side. BC by, before AD I taken, now I have to take CD. So BC by CD ratio is equal to one more right angle opposite AC and this right angle opposite BC. AC by BC. These ratios are equal. These two ratios are equal. Again we have to do cross multiplication. Cross multiplication. If you do the cross multiplication, BC into BC, BC square, AC into CD, CD into AC. This is equation number 2. That is equation number 2. Now we have to add the first equation and second equation. Adding 1 and 2 equations. Adding 1 and 2 equations. What is the first equation? ABC square. This is LHS of first equation. Second equation LHS BC square. AB square plus BC square is equal to RHS.
AB into AC
Plus next RHS of second equation CD into AC. Now see here, AC common. AC is common. What is remaining here? AD plus what is remaining here? CD. This is equal to AC into AD plus CD. See the diagram. AD plus CD is equal to AD plus CD. If you add these two, it is equal to AC. AC into AC, AC square. So what is LHS? AB square plus BC square is equal to AC square. AB square plus BC square is equal to AC square. We got. This is a proof. Hence, so this is a proof of Pythagoras theorem. So once again I will repeat. Listen. Pythagoras theorem means it will exist in the only right angle triangle. In a right angle triangle, the square of hypotenuse is equal to the sum of the squares of the other two sides. That is a statement. And what is given means ABC is a right angle triangle, right angle at B. And next, what we have to prove means hypotenuse AC square is equal to AB square plus BC square. For proving this, we have to construct BD perpendicular to the AC. So we have constructed. Now proof. So we have to take two pairs of triangles. First one pair of triangle we have to show those are similar to each other. Next one more pair we have to take, those also we have to show similar to each other. First which two triangles we have to take means ABC, big triangle, and next ABD. These two triangles we have to show similar to each other. We have shown by AA similarity. Next, corresponding sides ratios are equal. So I taken these two corresponding sides and we got first equation. Next, second pair, what we have to take again, big triangle and second small triangle. Here also we have to show that these two triangles are similar to each other by AA similarity. I shown. Next, we got corresponding sides are equal and we got BC square is equal to CD into AC. This is second equation. So these two equations we have to add. If you add LHS side and RHS side, we got like this. In the RHS side, AC is common in first and second terms. AC common. Remaining AD plus CD. AD plus CD. AD plus CD. In the diagram, this is nothing but AC. AC into AC is equal to AC square. So we got AB square plus BC square is equal to AC square. That is a proof of Pythagoras theorem. Okay, clear? Everybody understood?
Yes, sir.
Okay, thank you.